All right, super. We are pleased today to have again Dr. Kate Vavra-Musser, who's going to be sharing her expertise about mapping and data visualization using R. And the things that Kate shows are going to be available as through Jupyter Notebooks on the iGuide platform. So I'm going to turn it over to Kate.
Hey, thank you. Thank you so much, Tana and Anna. Let me share my screen really quickly.
And again, if there is no need to try to log in and follow along live with Kate, if you watch uh, her demonstrations, you'll have the instructions to be able to go along later at your own pace. But if you do have some questions, you can put things into the chat, and we'll do our best to try to troubleshoot along.
Okay, thank you. So, as Diana and Anna have outlined, there's a couple of links to follow for today to get with started with the Jupyter, the iGuide platform, and all of those links are in the chat in my link tree. But I'm going to get started now and talk a little bit about this project that I've been working on. So today's particular today's particular talk is going to focus on mapping and visualizing spatial data, specifically focusing on data that has been previously downloaded from the IPUMS NHGIS repository. So for anyone here who's from the IPUMS, coming here from the IPUMS mailing list, we're going to be focusing on IPUMS data. But this can be used, this kind of workflow can be used with any social data or spatial data from whatever source. Why did I create this project? Data analysis involves multiple tools and data sources and often multiple people that you have to collaborate with. So my goal was to create a series of notebooks that can be reproduced and used as kind of a set of modular notebooks that together create a reproducible workflow for your analysis. So each of the notebooks in the project kind of is a chunk of that kind of complete analysis that potentially you use as part of your own work. So this is going to showcase many ways that IPUMS data as well as spatial data in general can be used in R and provide a source of code which can be modified for your own needs and tailored to your own needs for your own projects. All of the notebooks that we'll be using today, as well as all the notebooks in the project, are freely available to use and download either from the iGuide platform or through my GitHub, and you're welcome to use them, modify them in any way that you like. So the overview of the project is the R Spatial Notebook project is a series of notebooks, as I mentioned. If you go to my website, which is a link is here, as well as in my link tree at the very top, you can see the overview structure of the entire project, as well as all the notebooks that are available, as well as those that are in development. And hopefully understand kind of the structure, which is a little bit like a book structure, showing all the notebooks that you might need for a R workflow using spatial data. So today I'm going to be demonstrating 3 notebooks from chapter 6, which is the mapping and visualization notebook, or chapter. You can access those directly into the iGuide library of elements through the links on my website, or you can access the links directly in the link tree that I shared in the chat. So it should be pretty easy. It's 6.1, 6.2, and 6.3 are the 3 notebooks. We might not get through all 3 of those, depending on time, but I'm going to try to at least get through 2. And they're all available for you to work with and use whenever you like on your own time. All right. So all of the links in the link tree or on my website will take you to a landing page that looks like this. That has a little bit of information about the notebook itself. as well as a link to run the notebook and some info or a preview here. So this, for example, came directly from clicking on the link in my website or clicking on that link in the link tree. And once you click on the links, it will spin up the iGuide platform, and you'll be able to view and work with the notebook within the platform. Can you please share the links again? Thank you, Diana. Yes.
Yeah, Kate, we'll take care of things like that. Just carry on.
Okay. Okay. All right. So the first three notebooks in chapter 6 are, the first is focusing on mapping fundamentals, and then 6.2 and 6.3 are focusing on different types of mapping, so thematic and reference mapping and chloropleth mapping. So I'm going to start with the mapping fundamentals. There's a lot of additional information and text in each of these notebooks that I'm not going to go over in depth right now, but those are kind of like contextualization information for you if you are working on them on your own. The big things to understand, or the big things to remember that we won't go over in detail right now are each of the notebooks has some prerequisites that are other notebooks from the project. I'm going to skip over those today, but this notebook kind of hopes that you understand or have a basic understanding of SF, the SF package for simple features, as well as understanding CRS, working with CRS within R. There's also some required data for each notebook, and you will need to also download that or use the, or load that into the iGuide platform in the same way you did a notebook. And you can do that by either um, clicking on the link and doing the same thing to access the data source within the iGuide platform, or you can download it from my GitHub and upload it. Okay, so I'm going to get started with the first notebook. It requires this US states boundaries file IPUMS NHGIS.zip to be in your working directory. You can see that I have it right here available for me to work with. So what this notebook is going to do is going to quickly go over a couple of just sort of methods for mapping spatial data. We're going to go over working with plot, the plot function in base R, which is a very nice, quick way to really rapidly look at data mapping or spatial data and maps. We're going to go over ggplot, which is if you've been working in R, you're probably very familiar with ggplot, but it's a method for creating really beautiful production-ready graphics and maps, including maps. And we're going to go over how to use ggplot with spatial data to create maps. And then I'm also going to go over tmap plot, which is a somewhat similar to ggplot in the way that it sets up objects, but it is dedicated specifically to mapping. So it has a lot of additional capabilities that are kind of a little more oriented towards mapping, whereas ggplot was sort of designed broadly for visualizations and then has kind of a mapping sort of addition to it. So in each of my notebooks, there's a setup section which has just information about all the required packages and what functions we'll be using from each of those packages. So that gives you an overview if some of these packages are new for you. If you are working on this with this notebook on your own machine, you will need to uncomment and install and run this command to install your packages. But since we are working on the iGuide platform, you will not need to install those. They'll already be installed. Make sure, however, forgot about this, make sure that you are on the iGuide EWDR kernel. So over here in the corner where my mouse is, there's this kernel name. If you launch the notebook directly from the repository, it may open in a different kernel. So click on that kernel and then you can switch it to something else, and you want to select that iGuide EWDR, which has all of the packages that we need installed already. So everything's installed, so we're going to run the command to load all of the libraries. And if you aren't familiar with using Jupyter Notebooks, the way to run an individual cell of code, so that's this code chunk, is you can either hold down Shift and press Enter to run it. You can press Enter to run it and switch to the next cell, or you can press this play button while you're inside of the cell to run it. If you get warnings like this, don't worry too much about them. I guess none of these are warnings, kind of feedback like this. Don't worry, but we have all our packages now loaded. So the next thing we're going to do is we're going to load our data. Our data is in our working directory as a zip file. So first we use the base R unzip command, and then we'll use the stread from the SF package to read in the shapefile component of what's in that zip file. So if you're familiar with shapefiles, you know that a shapefile contains all of a series of files, including a .shp. So we'll unzip that zip file. It already has unzipped in my working directory, but this will just override that. That will open up all those extra files, and then we will read in the SHP component into this USA states object. You can see here that reading in the object gives us a little bit of metadata information. We've got a simple feature, so a spatial data set of simple feature in the simple feature format of 52 features with 4 fields, so 4 attributes. So those are our 50 states plus Washington, D.C. and Puerto Rico. It tells us a bounding box and it tells us CRS. So lots of helpful information, even just in that read step. But let's also take a quick look at the first few rows of data using the head command that's just in base R to look at the first few rows of a data frame. And our spatial data is going to be stored in an SF object which behaves just like a data frame. So pretty much anything you do with data frames in R, you can do with the SF object. It's very handy, even though you have this complicated spatial data, that you can manipulate it like a data frame. So there we go. Here's our first 6 lines. And it shows these first 6 states. So we can see here what our attributes are. We have those 4 attributes: the state FIPS code, state USPS code, name, and region number. And we also have this special column on geometry. If you aren't familiar with working with the SF data, I recommend taking a look at my SF data overview notebook in the R Spatial Notebooks series. But we're going to go kind of skip over some of like the details of what this data structure is and go right into working with the data. We're going to do one quick step before we start mapping, and that's going to just simplify our data a little bit. I'm going to remove 3 states, Alaska, Hawaii, and Puerto Rico, just so the maps are a little cleaner. And we don't have those extra states that are quite far away from the contiguous US. And I'm going to rename all of the regions to a more readable format. These are the census code regions or census regions. Here I'm just using dplyr with the pipe function and saying I'm going to filter to anything that's not in that the state USPS abbreviation is not in this list. And then I'm going to mutate or do a mutate to do a recode to recode the region attribute this way to just say I'm going to switch all these names to old name, new name, old name, new name. This little chunk with dplyr, this isn't really the focus of this notebook. There's other notebooks that focus a little bit more on working with dplyr and managing your data, but this is just a step for this particular notebook to make it a little bit easier for us to work with. So run that. Now we're going to jump into our first method for mapping, which is using base R. And you might be asking, why would I use base R? This is a really simple kind of janky way to plot things, but I personally really like using the base R plot function when I'm doing quick data analysis, just checking out the data that I maybe just loaded, or if I'm doing something like I'm modifying my spatial data and I want to do a quick check to see that it looks the way I want it to, or it's projected the way I want it to. Plot is the quickest way you can possibly plot the data. If you're using ggplot or tmap or something else, things become a lot more complicated. So this is a great place to start. And it's very easy to plot geometry of your object. So here I start with my USA states object. I'm going to use the stgeometry function from SF to say I want show me the geometry, so show me just the outlines of my object and plot that. And what it will give me is the most very basic plot that I can make of my data, which is just going to be the outlines of the objects. And there's my 50 or 49 states, including Washington, D.C., plotted in a very simple map. Base hour plot has a few options, not very many, but you can do a little bit of styling. You can add a color that'll be a fill color for the polygons. You can change the border color, so that's the border of the polygons. Add a title. You can add labels, things like that. This is show or don't show the axes, so I'm adding the axes in. It's not very pretty, but you can do a little bit of styling. You can also plot attributes. So up here, I'm plotting specifically the geometry, so that's just saying just those outlines. But down here, I am saying, okay, I want you to plot a specific attribute. And we do it in this format where I say, where you take my object and then specify an attribute in square brackets in this way. So that will plot a similar map, but instead of just every polygon the same and just showing us the outlines, it's going to visualize based on that attribute, which is that region code. And remember, we had those 4 codes, Midwest, Northeast, South, and West. And it's just giving us a color for each group. Similarly, we can do multiple attributes in a grid by plotting a list or plotting 2 or more at the same time. So using that same functionality, and I've removed kind of the styling, but the same functionality, but instead of one attribute, I have a list of multiple. So now we have this very simple map with a map of the region and a map of the states, which isn't very interesting, but it's giving a different color to each of the unique states. Okay. All right, so the key takeaways for using base R. It's very quick. It's fantastic for, I just loaded my data. I want to take a look, make sure it's what I think it is. Is it projected correctly? Is it everything that I thought it was? Maybe I'm going to do a filter or clip something out, and then I want to check again to make sure I did that correctly. So it's really great for those very quick and early steps of your process. But it's not fantastic for making finalized maps if you want to do something for a presentation or a publication. So that's where we start to get into a more detailed, more advanced form of visualization with ggplot. So base R is great, but let's move into ggplot. If you are a common R user, as I mentioned, you probably know about ggplot, but if you aren't, this may be a little bit new and different. The ggplot framework, the way that objects are set up are a little bit different from other things in R. So we're going to go from the very beginning on how to set up a ggplot object and start from there. So here we're going to do basically what we did in our first step with the plot in the plot section. We're just going to plot our outlines of the USA states objects. And we've got the minimal number of things that we need for a ggplot object to show you how that object is set up. So what we do to set up a ggplot object is we call the ggplot function. We specify what data we're using, so we have that USA states shapefile or SF file that we're using. And then to add more functionality, we use this plus and do a new line. So that's kind of a unique way of framing a function in R. But the next thing that we will do is we'll add this geom_sf functionality, which basically says to ggplot, this plot that we're doing is a spatial plot. So normally ggplot, well, there's other types of functionality that ggplot can do, such as bar charts and line charts and so forth. So whenever you initiate a ggplot, tell it what data to use. You next have to say, okay, this is the kind of thing that I'm doing. And this geom.s or geom_sf is saying this is a map of spatial data. And then I'm also adding this theme minimal addition. This is actually optional, but it's saying that I want a clean minimal theme. And that's just going to make things a little bit cleaner and easier to visualize for this particular visual. These also, you'll see it's going to take a few moments. So you'll start to understand that the ggplot functionality is a little bit slower than plot, and why, especially once you get really high detail or large data that you'd want to use plot whenever you can before you start building your really nice visuals. So it may not look too different yet, but this is our very beginning of the ggplot map. Whoops. We're next going to add a couple of visual stylings similar to what we did with plot. So the next thing we'll do is add, specify that we want a particular attribute to be visualized. So you can see that this framing of the ggplot looks exactly the same, except we added one thing here, this AES fill equals region, whereas before this was just empty. And what that's saying is we want to add an AES as aesthetics. So we want to say we have a map, but we want the aesthetics to reflect this region attribute as the fill. So what that's saying is this is a map, and we want the polygons to be filled with the region data. So that's going to do similar to what we did with the plot section, the base art plot section, is it's going to do a random set of colors or a set of colors that to each of the different regions. So that was an example with categorical data. We can do the same with continuous data. And before we run this version of the map, I'm going to make a little continuous attribute. So we don't have any continuous attributes in the data right now, but we can produce one using the ST area, which is a built-in area calculation function. We're gonna calculate the area of each state in square miles. So what we're doing here is I'm gonna say take the area of each object in USA states, turn that into a number, and divide by this number, which is converting it from square meters to square miles. The object is USA states is originally in square meters because um the that's corresponds to the projection that it is in. If you're interested in knowing what the units are, you can take a look at the projection metadata. So what that does is then I'm going to store that to a new object or a new attribute in USA states called area SQMI, area square miles. So now I'm going to have a new object or new attribute that's square miles and a numeric continuous value. This isn't going to be very exciting. It's just going to visualize the map in terms of its square miles, but it's a continuous variable for us to practice with. Similar then to the categorical map, I'm going to say fill the objects with instead now the area square miles variable attribute. And I'm going to add one more step in here. I could run it without this step, but I'm going to add this extra step just to show you another thing that I want to cover in this notebook, which is the Viridis scales and other continuous scales and kind of a little bit of intro to color theory with maps. So what this is doing is it's saying, I'm adding another element here to my ggplot, and I'm going to fill the scale with a continuous Viridis scale fill. So that's going to be this color pattern. And this command comes from the Viridis package, and it's kind of a extension to the ggmap functionality that brings Viridis scales into ggmap. So I'm saying, all right, I want a continuous Viridis scale color scheme. And then I'm going to also add a label name, a legend name, and This is a option that says add commas to the legend numbers. So here we have, pretty big numbers. So I'll specify that we want commas. And otherwise it will give us just a non-comma number. So the outcome then is the default Viridis scale, which is yellow to purple. And you can see that we've updated our legend title. We have commas in our legend, and then we have this very nice continuous Viridis scale that's applied to the states. Again, not super interesting data, just visualizing the size, but you can get the idea of using continuous data and using Viridis scales in ggplots. I'm going to pause right there and field if there's any questions. We have same regional groups, yeah. Okay. Looks like everyone's doing okay. Great. Okay, so we'll keep moving along. So again, just should be four. Again, if you are familiar with ggplot, you'll know that there are a million ways to customize your visualizations, and that's also true with maps. I'm not going to go into everything that could possibly be done, but a few that probably are useful and interesting for you are adding labels, including titles, captions, things like that. So here's back to our region map. So that's the categorical region map. I'm going to add this labs component with a couple of extra things here, including an overall title, subtitle, caption, which is going to go on the bottom, and a fill. Oh, that was already starting. Oh, fill census region is giving a label for the legend. If I'm using the Viridis scale, like up here, I can specify that in the scale Viridis. But down here, without the scale Viridis, when I'm using categorical data, for example, I would use fill to specify that that's the legend title. That's relative to the fill that I'm using. So you can see here now we've got our same categorical map again, got a nice title, subtitle, got our legend title, and we have this caption at the bottom, this with data source, and you can put your author name, things like that down there. And there's a lot of other options you can do in terms of resizing these, and you can change the themes, all kinds of things you can do with ggmap or ggplot, I mean. That we won't go in depth into, but this is to get you started. Okay. The next thing, other than labels that you might be interested in working with, are the size and color of the borders. So the default borders are black and there's thickness 1 and of transparency 1, which is fully opaque, not transparent. But you can set the details about the borders in the AES, the aesthetics section, along with your fill. So I've added here a couple things, including that I want white borders. I want them to be very thin, thinner than that 1 default, and I want them to be a little bit transparent. 0 is fully transparent, 1 is fully non-transparent, and then I have still my title and legend name. I've also asked for the legend be at the bottom. The default, as you can see, is to the right. So you can remove the legend, which is the extra object here in the theme section, legend position. They've also just trying out a different theme. So far I've always been using this minimal theme. There's a lot of available themes for ggplots. And we'll take a look at the theme void, which is for maps, removes the axes. So we will no longer see these latitude and longitude values. Here we go. So we've got our white boundaries. We've got a legend on the bottom. We've no longer got our axes. So a few other styling options that you have. Is there an alternative? Yes. Oh, thank you. Thank you. You guys are okay. You guys are so helpful. All right, excellent. A couple more things. So controlling map extents. So another thing we can do is specify that we want a particular region to focus on within our map. So by default, ggplot will plot the entire extent of whatever data you're working with, but you can also say within the chords SF, that you want an X lim and Y lim. So that's limits for the longitude and latitude of your data. You can also on the fly change to CRS. So rather than um, within R, you can obviously project your data, but this option will just do it on the fly. So it's only reprojecting for that map, not reprojecting your base data. So this is going to be a kind of zoomed in version of the map to just Minnesota. So this is looking at the latitude and longitude min and max for like the bounding box of Minnesota approximately. And I'm going to reset the CRS just kind of as a practice for that to show you how you would do it. You can specify a CRS using its CPSG code, or you can also um, do something like this using the STCRS. And if you have some other map data, and that will say, okay, I want the CRS to be the same as this other object, which is pretty handy. So here's my extremely interesting map of Minnesota. So we see that we have zoomed into a particular area. Um, this was this working earlier. This one is not a pretty map, but you can also, in the same way that you do with other ggplots, you can use this facet wrap command, which basically says, I want to create a multi-part map based on a specific attribute. So this is pretty complicated, and I told you this isn't super pretty, but what it's saying is I want to fill the polygons with the area square mile information. So that's that continuous information again. Here's some more aesthetics with the outline and the size of the border. But I want to create this facet wrap command. So I want to make a um, multiple maps, multiple chunks of the map based on the region. So I'm breaking out, visualizing each of these polygons by the size or the area of the polygon, but I'm breaking out each map by region. And then some of the stuff that we have done before, again, the scale viridis, some labels, look, and here I've moved the legend to the bottom with some more detailed legend information, legend options to make it look a little nicer. This isn't beautiful, but you can imagine that maybe if you have data that has data stored by, different years or something like that, it's a great way to compare different categories of your data or different versions of your map next to each other. And this is, I set up, sorry, I forgot to mention this, but I set up here with a 2-column grid. So you can also change the column numbers. So if I said I want one column, they'll all be in a row, or sorry, in a column together. And so you can kind of modify that based on the way that you want them to be set up. All right. So I know somebody mentioned color palettes, and yes, there are lots of available color palettes. I talked about the Viridis palette, which is, I think, the best to use for continuous data. It's really great because it is optimized for color blindness as well as color defi for eyesight deficiencies. So if you're using continuous data, I highly recommend using Viridis. You can view all of the Viridis color palettes here. If you forget that link, if you just Google Viridis color palettes, you can find this image all over the place. But these are the names. The Viridis one is the default, but we've got a lot of options here. So here I'm going to update this where I have the scale Viridis C, a continuous Viridis scale, and I've updated to a plasma option. I'm also going to inverse the direction. The default direction is that purple is the high value, purple is the low value and yellow is high, so maybe I want that the other way around. And then again, adding our legend name. So now I've got this visualized with the Viridis, the plasma Viridis palette reversed. So the yellow is low and purple is high. Another great option are the color blur palettes. And you might be more familiar with them if you've been working with R longer. They've been around, I think, a little longer. So here are the R color brewer palettes, and you can also call these in a similar way, but instead of the scale variant C or scale variant D for discrete, the categorical data, you can use this scale filled brewer for discrete palettes. So that's categorical palettes. Scale view distiller for continuous palettes, and scale view, I guess the same. Scale view distiller again for um, diverging palettes, and I'll show you the difference between those. So first I'll start here with using our categorical region variable with the pastel one color brewer palette. So I'm going to say, okay, I want that scale view brewer using pastel one, and I'm going to name it region. That's the name it's going to show up with the legend. As that's running, oh, there we go. So if we look at our color brewer palettes, you can see that there's pastel one. So use the first four colors of that ramp. Here's the example of the continuous palette. So I'm going to use the yellow to green palette. Similar to Viridis, you can specify the direction, but I'm going to say, okay, I want it in the regular direction where yellow is low and green is high. And you can also use diverging palettes, which go from dark color to light color to dark color instead of light to dark. So here's my continuous palette. And then I'm going to do one more with spectral. This one I am going to invert so that blue is the bottom and red is the top coded for this. And you can see that we've got this the same data visualized in diverging color palette with red at the highest and blue at the lowest, and this kind of middle color of this like light yellow in the middle. You can also specify manual colors. If you want help getting hex codes, you can specify these as hex codes. You can use a hex code picker. This is just one of many on the internet, and it'll help you get the hex codes for a particular color. But I've created a little extra object here that associates a particular one of my regions with a particular hex color. And then I've used that in scale fill manual as the values of my scale. And that'll just be some beautiful custom colors that I've selected. Okay. So the takeaways, unlike plots, ggplot will give you a lot of amazing options and customization functions for making really beautiful production ready or publication ready maps. So that's the space that you want to go to when you're creating your maps for your any kind of finalized version. And the last thing that we're going to go through in this session, and I'm going to try to go through quickly just so we get a little bit of intro into at least one of the two other notebooks. I'm going slower than I expected, is tmap. So tmap is a bit similar to ggmap or ggplot in that it sets up objects kind of in this similar plus and then another component way. But this package is specifically just for thematic mapping, for mapping. So anything that maybe is a little bit unintuitive because ggplot is originally designed for just generally visualizations. It's a little more intuitive for mapping. I don't know. I haven't used a lot of tmap in my work, but I'm getting really into it. It's really some really lovely maps. So here's our version of our most basic map that we can make. So we have here is we start with a TM shape object. We specify that we want our USA states data, and then we add another functionality to say, okay, just I want the borders. Very simple. We're going to add a little attribute now. So again, TM shape with the USA states. And this time I want polygons and I want to visualize them by, again, that region. And I'm going to set the palette right here. This is using set 2 from the Color Brewer series. So that is going to make a categorical map. And you can see it's a little bit kind of what I would say maybe more what a cartographer would do as our first pass rather than ggplot is a little bit, you kind of have to finagle it to get to a nicer version like this. So I really like tmap for that aspect. We're going to go a little bit more in depth. So we've got, again, our shape with the data. I'm going to specify that we want those categorical regions. And then we're going to add a scale bar, going to add a compass, and we're going to add this little layout section that has the title, the position of the title, and the legend position. So these are a couple of things like the compass and the scale bar that you can do in ggmap, but you need the extension ggspatial, so they're not built in. So this is kind of, tmap is giving you all these things sort of already built in. It's not great. So now we have a region map. We have our legend. We have a scale bar. We have a north arrow here. Um, you can mess with the spacing a little bit. I didn't do that very well, but you can see you're starting to get kind of these extra elements of the map that you would have for a finalized cartography map. There's a couple different built-in map styles, which I really like about tmap. So other than just the base version, you can specify the map with this TM style class or TM style aspect addition. So I'm going to map just our regions again, just show you a couple of the options that you have. So this one I really like. I just think it's really pretty. Um, so there's a lot of kind of default built-in, just sort of stylings that you can do that are much more kind of map and cartography oriented than what you get in ggmap without a lot of finagling. Yep. All right, and there's also, I'm not going to do that here because it's not very compatible with Jupyter Notebooks, but you can also switch to an interactive version by switching to the tmap view. The base is tmap plot, which is a static map plot version or kind of setting. And you can do the exact kind of same thing, and it will give you an interactive map. And I encourage you to test that on your own, maybe within RStudio. All right, so key takeaways from tmap. It's similar to ggmap, but a little more map focused. If you are familiar with ggmap already, it's probably easier to go from there and start mapping with that. But tmap is a great place to expand to a different method for mapping finalized kind of production ready maps. So I encourage you to explore into that if you haven't before. And that is, I have a little table here with kind of a comparison of the three approaches. And that is it for this particular notebook. I'm going to switch to the next one, but does anyone have any questions before we get, everyone here is being so, oh my goodness. Yes. Yeah, data with multiple years. Wow, okay. Everyone looks like they're answering each other's questions, which I love. Thank you so much. Um, how do you add Hawaii and Alaska so the map does not stretch too much? Um, do you mean how do I map with Hawaii and Alaska, but so that's not stretching? Yeah. So it wouldn't, it's not as easy as like if you were using a desktop GS where you maybe would have like a cutout and you'd have Alaska or Hawaii there. I don't have a good answer for you. I think that you may have to do a lot of finagling to add a second map and then um, map those two together. I can't answer that really quickly. It's not easy. I'm sorry. Yeah. If someone else has a really if someone else has a really good answer, please let me know. Some people add them under the map. Can this work with R Markdown? This unfortunately cannot work with R Markdown. It's you can copy the code into R Markdown and run it that way, and that would work. I'm in the process of creating R Markdown versions of these notebooks so that they can more easily work in, our studio or whatever. But for this project, I was doing it for the iGuide platform, which is uses Jupyter Notebook.
So
Yes,
Kate,
awesome. So some people have some ideas. Yes, was that Diana?
yeah, it is Diana. So, but Kate, when you do other things with our Markdown, they're going to be available on your own page, right?
Yes.
Yeah. So we'll make sure everyone's got those links so that they can follow up with your great collection of resources separately.
Yeah, if you want, please, if you're interested in our Markdown versions, please join my mailing list. I don't know when I'm going to release those. It'll probably be like a little while. So if you'd like to keep up with the project, please do that, and I will definitely let everyone know when I have our Markdown versions ready to go. Sydney, that's probably what I would do. Honestly. Yeah, yeah, the patchwork is I talk a little bit about patchwork. I'm very new to patchwork, so if anyone can give me, information about patchwork, that's great. Patchwork is a kind of a more um in-depth version of doing kind of the same functionality as a facet wrap. Why can't I minimize it? Okay. All right, so I think I think instead of doing two, I'm going to skip right to three, core path mapping. It's just going to use a lot of the same things that we were doing in chapter one, but a little bit more specific to core path mapping, including doing a normalization step and things like that. So this is 6.3. I'm going to use I've got 10 minutes. I'm going to use two sets of data for this. I'm sorry, just one set of data, two sets of data for 6.2. For this exercise, we're going to use this decennial population data for the state of Minnesota that I previously downloaded. If you want to go through the steps I did to download that from IPUMS and HGIS, I did that in the chapter in this notebook, I think chapter 4. Oh no, that's just in a previous notebook. It's also downloadable. But this is the example NHGIS data file that I produced in an earlier notebook. So for this, we're going to use a lot of the same packages, as well as a new package, this class int package, which helps us create classification intervals. Again, I'm going to install all of my packages and then unzip and read in my object, which is this NHGIS, IPUMS NHGIS example zip file. And I'm going to read it into this counties object. So one thing that we didn't really do a lot of in the previous notebook is a lot of initial inspection of your data. And this is always something that I like to do. And when I'm reading in the data, as we mentioned, it gives you a lot of great overview information on your spatial data. But I also like to take a look at, we did before, the first few rows of data and a list of all of the column names, so list all the attributes, as well as just a check of the metadata of the CRS, which I can do with this stcrs command from SF, the SF package. So we can see here we've got a lot of demographic information from this is the 2010 census for the state of Minnesota. This is at the county level. So I'm sorry, this is the state of California. It's the state of California because I didn't update the version that's here. But if you're using the one that's on the website, it's Minnesota. Just pretend that my pictures look like Minnesota. I'm not going to upload the new one. I'm so sorry. But anyway, the state of California, we've got the county name, some information on the county. And then we've got these variables here. Where are they? No, they're being hidden. Oh, the variables here. And those are the four censuses. So 1990, 2000, some that are hidden, but 2020, the L at the end and the U at the end. So you can see here we've got four versions of 2020. Those are the lower and upper confidence limits for the data. That's just how this is exactly how it comes out of IPUMS. So if you do the IPUMS API and download this data or work through this process with the notebook, you'll get exactly this data directly from IPUMS. So taking a look at what we've got, we see we've got information on population, a lot of metadata and administrative data about the counties, and let's get into our pre-processing. So one thing I didn't do in the previous step, but what it's useful to do before you start mapping is to make sure that your spatial object is valid. So make sure all of your um, make sure all your polygons are valid. You can also do this extra step, which is just double checking, ensuring that it's an SF object, which it will be because we have read it in as an SF object. But if you're working with a different form of spatial data, you might want to also do this step. But the important step here is this make valid step, which often takes quite a lot of time, but validates all of your polygons. So if there's any kind of issues where they aren't matching up or snapping together, things like that, or corruption in them, it will fix this, which is nice. If your polygons are not valid, usually your maps will not work. We're also going to do a quick CRS transformation using the stcrs, or sorry, sttransform function from the SF package. So we'll take our counties and specify the new CRS. It's going to make it a little bit easier for us to calculate area. And you can see now the new CRS for the county's data is 5070. Okay, so the another important step before we start mapping mapping data in choropleth maps is understanding kind of different ways that we can normalize data. So usually when we have data it's directly downloaded from IPUMS or another source, it's just the raw counts. And if we map the raw counts data, which is not unuseful, we usually get something like this where some counties, like this county here, which are actually like have quite a low population density, but are very, very big, are visualized as kind of one of the bigger counties. And we all know this problem, right? In mapping. So what we want to do is normalize our data. So we're going to quickly do just a calculation to calculate the number of people, so the population divided by the area. So I'm going to do that all in this one dplyr step. What I'm going to do is say I take our counties data, run it through the dplyr mutate command. I'm going to make a new attribute that's the area in square kilometers. So I'm going to take the ST area divided by this, the base data is in meters, so divided by this to get square kilometers rather than square meters. And then I'm going to create a population density for the 2022 census data by dividing the 2020 population by square kilometers. And then we're going to convert that to a numeric. So we're going to remove the units on that. We'll do that and then look at a little summary. You can see that we have a range of now population density rather than population, which we can now map. So now we're looking at population density versus population. If you're asking me where is the really high density one, I can't see it. It is right here in San Francisco. That's skewing the entire states. But what we have done here is we have, here I'm setting up a ggplot, saying we want that population density filled. Again, using this Veritas continuous scale. I'm using the plasma again this time, and specifying the label for the legends. This is a new addition to specify the color for missing data. So if I have any missing, it will be visualized at this gray 90 value and giving us our data here. Another thing we can do to make it a little, usually when we're working with especially population data, we want to also log transform that population density. So the next thing we'll do, I have also a step here to take a look at the data. You can see everything is very skewed. We've got that one county, San Francisco, that is skewing our data because it's so much more dense than everything else, and it's also very small. So what we'll do then is we can log transform our data on the fly in our ggmap, so our ggplot map. So again, specify our ggplot. This time, we also in the scale options, we add this transformation specification that we want it transformed or log transformed on a log 10 scale. We're also specifying the breaks, which rather than automatically creating breaks, which will just kind of be done on a continuous scale, we can specify exactly where we want the breaks to be. And you can see that the outcome is a much more useful comparison, or at least like a visually useful comparison for us to see where those high density areas are. And we're not getting so much noise just from that one little county. If you're used to using your desktop GIS, you know all about all the different classification methods, but here is some detail. I'm going to quickly just go through this, and this is the very last thing we do. This is a little bit of detail about all of your favorite classification methods. So, and how to create a set of breaks, so a set of classifications using each type. So our equal interval classification, before first creating an object that specifies the breaks, and then I used our class intervals command from that class int package that I loaded. Specify we want to use the population density, the number of classes, and that we want an equal interval. I'm going to then show what those breaks look like. Add the classification to that county's data as a new attribute, and then we will map that attribute. So we've created the breaks. I'm going to take a look at what they look like, and then we're going to add them by cutting the county's data at those breaks levels to create a new attribute. That's then what we're going to map. It's not very pretty, but that's your equal class interval classification. Quantile classification, you can set it up the same way with the quantile specification in the class intervals function. There's quantile, natural breaks, aka jenks, which is usually my favorite. Jenks, standard deviation. This is all using the same function, so we're just specifying the different version. And here's a patchwork. This is our first use of patchwork, which is kind of like facet wrap, but a little bit cleaner to use, where I'll first create like a object with each of these maps and then add them together in this little object. That's what I plot to show the comparisons here. And I think that is where I will stop. The rest of this is a little bit more on details on color schemes, more detail on what we went over in 6.1, but I know we're running out of time. So yeah, hopefully that was a good overview for you. And again, all of these notebooks are available through the iGuide platform or through my an easily kind of accessible and organized way on my website. Feel free to join my mailing list if you want information on new releases and kind of like release new notebooks or update new notebooks every month or two or so. Yeah, I'm so glad. I know, yeah, and I'm sure it was a refresher for some people and very new for other people. So I hope it was helpful kind of across the board. Yeah, thank you. I'm so glad it was helpful.
Thank you, Kate. As usual, covering super useful topics for a lot of data science needs. Thank you, everyone. This recording will be processed and put up on the iGuide website, and we'll use the registration information to send everyone an email and make sure you've got the links. And stay tuned to the iGuide website for other upcoming VCOs.
Thanks,
All right.
everyone.
Thanks
Have a great
again,
day.
Kate. We'll be in touch soon.
Okay.